In this video, I'll discuss delusion in Dedekind cut, which is in line with delusion in the concept of convergence and limit. A Dedekind cut is a partition of rational numbers into two sets A and B such that all elements of A are less than all elements of B and A contains no greatest element. The set B may or may not have a smallest element among the rational numbers. If B has a smallest element among the rational numbers, the cut corresponds to that rational number. If B does not have a smallest element among the rational numbers, this cut between this partition of rational numbers A and B is considered to define an irrational number. Every real number, rational or not, is equated to 1 and only one cut of the rational numbers. The number line where every real number is defined as a Dedekind cut of the rational numbers is considered a complete continuum without any gaps or missing points. However, even though an irrational number R is related to only one A and B, which is the Dedekind cut of that irrational number, A and B should be related to more than one irrational number in order for the number line to be continuous. I'll give you two proofs. Proof 1. Consider a unit interval of 0 and 1. The number of rational numbers in 0 and 1 is countably infinite. Because A and B determine each other, the number of ways to partition the rational number in 0 and 1 into two parts, A and B, is the number of ways of A. The number of ways of A is the number of the rational numbers in 0 and 1, which is countably infinite. If a certain partition A and B defines only one irrational number, the number of irrational numbers defined by A and B will be countably infinite. However, the number of irrational numbers in 0 and 1 is uncountably infinite. Cardinality of real number is larger than cardinality of rational numbers, which is equal to cardinality of natural numbers. Cardinality of real numbers is cardinality of irrational numbers plus cardinality of rational numbers, which is larger than cardinality of rational numbers. If the set of irrational numbers were countable, then, because the union of two countable sets is countable, cardinality of real numbers would be countable. Therefore, cardinality of irrational numbers is uncountable. Therefore, each partition A and B should be related to more than one irrational number. And then I show you the second proof. Suppose a Dedekind cut A and B defining an irrational number R. And there is no nearest rational number R prime for R. Assume there is a nearest rational number R prime for R. Suppose R prime is an element in B, that is, R prime is larger than R. Let R prime minus R equals delta. Delta cannot be 0 because if delta is 0, R prime equals R. Thus, delta is larger than 0. For any delta larger than 0, there is n in natural number, such that 1 over n is smaller than delta by Archimedean property of your numbers. Thus, delta minus 1 over n is larger than 0. Suppose r double prime equals r prime minus 1 over n. Because r prime is a rational number, I prime equals p over q for some p and q. R double prime equals r prime minus 1 over n equals pn minus q over qn. Because pn minus q and qn are natural numbers, r double prime is a rational number. Thus, r double prime is a rational number smaller than r prime, and r double prime minus r, which is r prime minus 1 over n minus r, equals delta minus 1 over n, which is larger than 0. Therefore, r double prime is larger than r but smaller than r prime. That is, r double prime is nearer than r prime, which contradicts the assumption that r prime is the nearest rational number to r. Above can be done for r prime in A, that is, r prime is smaller than r. Because there is no nearest rational number to any irrational number r, no rational number in A and B are next to r, even with all the infinite number of rational numbers in A and B. Therefore, there has to be other numbers in order for the number line to be continuous. These other numbers cannot be rational numbers because rational numbers will be in A or B. Thus, these other numbers are irrational numbers. These other irrational numbers will share the same A and B, which define R. Therefore, A and B is related to more than one irrational numbers. In other words, an irrational number has a unique Dedekind cut. However, each Dedekind cut represents many irrational numbers. This has the same implication that the limit of a converging sequence is not unique. Please send critical comments to this address. Thank you very much.